Alright, so this is going to be the examples video for Target 1.1. Just a reminder of how the process worked for the examples. So the intro video, if you wanted to take notes, you could. It may help you especially if you're a visual person, in the sense of that you not only like to see it done by someone else, but you also like to see it done by yourself, by writing it on paper. That's great. You can still do that. You don't have to do that for the intro video. However, for the examples video, you are going to have to go through here and write out all the answers that we go through on these examples. And I may ask you to not only write the answers, but some particular parts of the problems. I won't ask you to write every question, but just listen for when I ask you to write something and make sure that you do write that down. So to start off, we're going to start here with question number 1, and it says the table below gives data from tests of a full-size bungee jump. Okay. Now it says if you look in this table, we've got the jumper weight, so how much the person weighs, and then the stretched cord length. So imagine you have this little person at the top of a bungee jump, and they're getting ready to jump off. Okay. And they're all excited. They're on a bungee jump for the first time ever. And so generally the bungee is tied to their feet, their legs somehow, and then it just kind of hangs down here. And then they jump. And as they jump, that cord is going to stretch out, right? Longer than it is at the current moment when they jump. And it's going to keep stretching and stretching depending on how much the person weighs, how high they are, gravity, things like that. So, but that's the problem that we see here, alright? So they're going to be jumping down and the cord is stretching out. Now, what I would like for you to do is to just look at this table for a second. Look at the variables. Alright, remember our variables in this problem are going to be jumper weight and the stretched cord length. And question A asks, which variable does it make sense to consider independent and which dependent? So we've got two words here that we need to understand what they mean. Independent is our first word, dependent is the second. So independent when we're using it to describe a variable, means it's the variable that is not affected at all by what the other variable is. Okay? And dependent is going to be the variable that depends on the other variable. So for instance, if we said jumper weight was the dependent, it would have to depend on how far the cord was stretched. If we said stretched cord length was the dependent, then that would depend on how much the person weighs. So if you think about this for just a second, I think you'll come to the quick conclusion that the independent variable, so this is what you're going to write down, the independent variable is going to be, oops, a little bit bigger, independent variable is going to be the jumper weight, and the reason being there is that the weight of this person, the person jumping off, has nothing to do with how far this cord stretches. They could get a really tight cord that doesn't stretch a lot, or they could get a loose one that stretches quite a bit. Okay, but that does not affect how much a person weighs. If you go bungee jumping, you're not going to ask them how much the cord stretches, and then that's going to affect your weight. Your weight will not be affected at all by the cord length. On the other hand, the dependent variable, okay, and I'm just going to abbreviate it DEP in this problem, the dependent variable is going to be the stretched cord length. Okay? Oops. So stretched cord length. And the reason we call that the dependent variable is because if you look at this table, depending on the person's weight, the heavier they are, and this makes sense, the heavier they are, the more that bungee is going to stretch out. Okay? Kind of like if you've ever used bungee straps to help tie something down or to hold something in place, like you may have seen someone in your family use it on a car or a truck or a van or something like that, to kind of keep things in place. If you've ever messed with those before, then you know that depending on the amount of strength that you use, it affects how long that cord stretches. Okay, so the same thing going on here. So the heavier they are, the longer that cord is going to stretch. All right. Now, part B says describe the overall pattern relating stretched cord length L to the jumper's weight W. Okay, so the overall pattern. So let's look back up here, and I think it's pretty obvious by looking at the table. But as the jumper's weight increases, we need to think about what is happening to the cord length. And I think we've already mentioned this, and it should be pretty obvious from the table, that as the weight increases, so does the stretched cord length. Now if you look real closely here, the amount that this table is increasing by each time, it is increasing by a total of 25 pounds, okay? And if you look at the stretched cord length, it's only increasing by 5 pounds at a time, all right? And it just keeps repeating that pattern. So every extra 25 pounds, the cord length stretches 5 feet. And that's actually what we're going to write down here, okay? So where it says describe the overall pattern, we're going to say something along the lines of for every 25 pounds of weight, and again, this is something you need to be writing down, for every 25 pounds of weight, the cord length stretches by an extra 5 feet. Okay. Now you could simplify that down and figure out that for every 5 pounds, that's only 1 foot of extra stretch length, or if you went all the way down to 1 pound, that's only like 1/5 or 0.2 feet. Okay, but it's fine just looking at the pattern and understanding that every time the weight increases 25 pounds, the cord length is stretching by an extra 5 feet. Okay, so and we may want to say for every additional, I want to actually add this word back in. So for every additional, so every time we add 25 pounds of weight, the cord length stretches by an extra 5 feet. Okay, so that's the overall pattern we see here. And if you remember anything from the linear unit, this means that as long as this is increasing by a constant rate, and so is this, the overall change is constant. So this is a linear function. Okay. All right. Question C. Use the pattern in the table to estimate the stretched cord length or the jumper's weight. And it gives us this function notation here, f of 150. So here's where function notation is coming in. So we need to think about what generally goes inside the parentheses when we write an expression as f of something, okay? And generally that's where the x variable goes. Now sometimes it won't be listed as x, maybe it'll be listed as t or something like that. And even in some cases you may not even see it written as f of x. Maybe it would be h of t or something like that to represent the height over so much time. But in this case we're comparing weight to cord length. And if you remember, we said that the weight was the independent variable. X is always what we use to represent our independent variable. Or generally when we use y and x, x is the independent, y is the dependent variable. So since weight is like our x variable in this problem, that means the jumper's weight must be 150 pounds. So this is the weight, okay, inside the parentheses. So that means we are looking to figure out f of 150. If we were to use this in our function, we should get out the other variable, which is our stretched, and I'm going to abbreviate this, stretched cord length. Okay, oops, there we go, length, and I'll just abbreviate it really short there, but stretched cord length. Okay, so I'm going to scroll back up to the table real quick, and I want you to just look at this table with me as we quickly identify that when we have a jumper's weight of 150 pounds, the cord stretched out to 60 feet. Okay, so we're just looking for the y variable, in this case the variable on the bottom, that goes with the variable on the top, which had a value of 150. Okay, so we'll scroll this back down and we're going to plug this in our answer. And for this problem, I'm going to need you to write out f of 150. Excuse me. F of 150. Again, with the 150 in parentheses, is equal to, this is where we're going to fill in the actual answer, but again, copy all this down, but that is equal to 60. All right. And where it says, what does this tell you about the cord length and jumper's weight? Well, since we sort of wrote some notes for ourselves here, that means that when the weight is 150, the cord stretches to 60 feet. long. Whoops. 60 feet long. Alright. Okay. So they gave us the weight, which is why we mentioned it first. When the weight is 150, the cord stretches to 60 feet long. Alright. Next question. Alright, and this is kind of working the opposite direction. Because notice this time, they don't give us the weight inside the parentheses. Okay? But they do actually write it out as f of w, which can be a hint that the w represents weight. So if you see a variable like w in the parentheses, this is what we're trying to find here. Especially, it's kind of obvious over here because it's asking us what does w equal. So if the weight is what we don't know, but 70 is representing something else, in this case it's going to represent the cord length, we need to figure out what weight will give us a cord length of 70. Okay, so I'm going to look back up here at the table, keep scrolling this down. Excuse me. So if we look at the table, we have a stretch cord length of 70 feet when the jumper weighs 200 pounds. So we'll scroll back down one more time, and we're going to fill this answer in right here. So 200 is going to be the weight that gives us a cord length of 70. So what does this tell us about the cord length and jumper's weight? Well, this time we knew that when the cord length was 70 feet, that means the jumper had to weigh 200 pounds. Okay? Had to weigh 200 pounds. Alright? And we're done. So, again, using function notation, we understand that the value that goes inside the parentheses is the x value, or in this case they called it w, and the value on the other side is kind of like our y, our dependent variable. In this case it was the stretched cord length. Okay? So once again, if they give you a number inside, that's the independent, you're supposed to find the dependent. If they give you the number on the other side of the equation here, then you're supposed to find the independent, or the x variable, w in this case, the weight. Right? So hopefully you understand this problem, and we're going to move ahead to start question number 2. Alright? So look at this one with me, and once again, just keep copying down the notes and the answers. As we go through these, you don't have to copy the problem itself, but just sort of follow along as we read this. So it says, to help in estimating the number of customers for an amusement park bungee jump, the operators hired a market research group to visit similar parks that had bungee jumps. The staff suggested that the pattern could be summarized with a rule, f of p equals 150 minus 5p, for the relationship between the number of customers, which is given by f of p, and the price, which is given by p. And it asks us to, in part A, find the value of f of 5, and then tell what does it tell you about the number of customers and the price per jump. So basically what happened is they have this market research group that looks at other parks and how much they charge for bungee jumps, and they come up with a pattern to figure out how many customers will show up, and we're going to call that f of p. Okay, so you may want to write this little part right here down. Number of customers is f of p, and we're going to compare that to the price, which is just going to be the p. Okay, so this is sort of a hint as to what is your independent and what is your dependent. The independent is the one that goes in the parentheses, so in this case it's p, which means the price, and that makes sense because the price they charge is going to affect how many people show up. If they charge too much, no one's going to come. If they don't charge enough, they're not. You are going to have a lot more customers, especially if you're giving it away for free. The downfall of that is you just won't make much money off of it. Okay, but we're not really concerned with how much money they're making just yet, just on how many customers show up. So find the value of f of 5. So once again, I'm going to write the equation down here. So I'm going to write this equation that we were given. F of p equals 150 minus 5p. Okay, and it says f of 5. So since the 5 is replacing where the p goes in our equation, okay, so we're just going to sort of transform this equation to represent when p is 5. So I'm still going to write it just like I did before. So 150 minus 5, but instead of p, I want to put in 5. And to show that it's not just 55, but we're plugging in 5 for the p, we put parentheses around to let us know that we are still supposed to multiply the 5 times the p. Okay? So this is something we can work out by hand, or you could plug in a calculator. But that's going to be 150 minus 5 times 5 is 25. And if you subtract 150 minus 25, you get 125. Okay? So that tells me that f of 5 equals 125. All right? Now, what that means in the context. It says, what does it tell you about the number of customers and price per jump? So what we're going to say is, and I'm going to start writing this over here, when the price, because that's what we were given to begin with, okay, that's what this 5 in the f of 5 meant. So when the price is $5, they will have 125 customers. Okay, so that's what we figured out, that when we charge $5, f of 5, and remember f of p was the number of customers, so f of 5 is the number of customers when we charge $5, and that will be 125 customers. Okay, problem below it, part B. Find the value of f of p equals 100. And what does that tell you about the number of customers and price per jump? So same equation here. I'm going to write it one more time. F of p, the original equation, f of p equals 150 minus 5p. Now this time they don't give us the p that goes in here, but they do tell us that f of p equals 100. So all of this, if f of p equals this and it equals 100, that means that this part and 100 have to be the same thing, because f of p is equal to both of these. All right? Kind of like if I said 5 is equal to 4 plus 1, and 5 is equal to 3 plus 2, we would all agree that that means 4 plus 1 is the same thing as 3 plus 2. Okay, that works out. So I'm going to take the right side of each of these equations, and I'm going to say, okay, then if that's the case, that they're both equal to f of p, then 150 minus 5p is equal to 100. So basically, I'm trying to figure out what price can I charge and still have 100 customers show up. Because remember, f of p is the number of customers, and it equals 100. So we just work backwards and solve this equation. So I'm going to take away 150 from both sides. If I do that, these 150s will cancel out, and I'm left with negative 5p that comes down. And 100 minus 150 is negative 50. Okay, one more step here. Divide both of these by negative 5 to get rid of the negative 5 in front of the p. These negative 5s cancel out. And if we do negative 50 divided by negative 5, let's go up just a hair. Negative 50 divided by negative 5, I'm left with p over here, and negative 50 divided by negative 5 is positive 10. Excuse me. So that means that if we still want 100 customers, if f of p equals 100, then the price that we charge, the p-value that goes in here, has to equal 10. And once again, p is the price. So what does this tell us about the number of customers? We can say if we want, or let's say when the number of customers is 100, or if we want 100 customers, something along the lines of where you're explaining that there are 100 customers, then the price has to be, the price, right? The price is $10. Okay? So, this is just showing you how to use equations and a table to work with the function notation. Hopefully this gives you a good idea of how this works. Once again, the letter that inside the parentheses of f of p, or f of x, f of w, whatever it is, that letter inside is your independent variable, which is kind of like your x variable if you think about it in terms of what we normally use with y and x. And f of p altogether, this right side of the equation here, is going to be the value for your y, okay, or your dependent variable. So, I hope this helped you out. You start to remember how a lot of this stuff works out. And feel free to go ahead and move on to the practice video, where you will just work through some practice problems on your own. Okay? And if you have any other questions, remember you can always comment on the video, or just to let me know that you watched the video. That would always be nice as well. Um, and then make sure that you've gone back and taken notes to show that you've worked these problems out. All right.